So like Azamal said, I'm Jake Ferriero. I work for the Google Cloud Professional Services team, and we try to make customers very successful using our data analytics technologies. Um, and what I'll be speaking about today is kind of some work and lessons learned that we've pulled out of a few customer engagements who had challenges with Airflow and Composer and data pipelines in general. Because as you know, it's not always easy. So let's get started. All right, so we're going to start today, even though it's called GitHub to Composer 123, we're going to start at 0 because we are software engineers. And we're going to talk a little bit of background about what Cloud Composer is, and it will help you for the rest of the talk. So the Airflow architecture in Cloud Composer is laid out like this diagram, where there are certain resources that live in your customer project in a Kubernetes cluster that gets deployed for you, and certain resources that live in kind of the Google management layer, which we call a tenant project. This includes the Airflow database and the web server. So the way that someone kind of interacts with Cloud Composer is either through the web UI, going through this identity-aware proxy, which Raphael has given a talk on securing Airflow with Composer, and through this DAGs bucket. So the way in which you would deploy a DAG in Cloud Composer is to drop some Python files in this cloud storage bucket. As you can imagine, this makes things very easy for when you're getting started. But if you have a lot of DAGs or a lot of people trying to collaborate on things, someone could drop a pretty malicious file in there and you'd be in trouble. So what we're going to talk about today is like some things you can do to automate away some of that pain. So one of the crucial things to understand the challenges of deploying to Composer is to understand this DAGs bucket. So it has different directories that ultimately get synced with different parts of that Airflow architecture. So I'm going to actually end up flipping back and forth between these two slides. The first is the DAGs and plugins folders, and these will be periodically synced from GCS to the web server and the workers. And just to remind you, that means that these will go to the web server and the tenant project, as well as the workers that are running in your Kubernetes cluster that lives in your project. This sync is periodic. It happens roughly every minute. But this can actually cause issues for us when we're trying to unpause DAGs, and I'll talk a little bit more about that later. But the other buckets of interest are these data bucket and logs bucket. And what's interesting about these is these are mounted only to the workers, and it's a different syncing mechanism called GCS Fuse. And basically, what this allows you to do is, through GCS, have an easy surface to get something on the file system of your workers. So key use cases for this might be, I want to drop a JSON file that has all my Airflow variables in it, so I can run an Airflow CLI command to import them. Or you're storing some SQL files that a BigQuery operator uses in your DAGs. And last but not least, these logs are pretty self-explanatory. This is just where we are syncing those Airflow logs. Okay, let's talk about testing pipelines, which is our first step. So CI/CD for Composer is CI/CD for everything it orchestrates. So it doesn't matter if we deploy good DAGs, if they run bad SQL queries or they run bad Dataflow jobs. So we need to make sure that we are testing everything around Composer before we're kind of deploying this DAG to any kind of staging or production environment. So some easy tests that we can run on things like BigQuery jobs are we can use the BigQuery CLI to dry run our SQL. And we can make sure we put our SQL files in a place where Composer can find them. One interesting point about this is until very recently with DAG serialization, you'll have the web server and the workers both parsing your DAGs. So what this means is if your DAGs refer to a SQL file, it needs to be on the file system of the web server and the file system of any worker. So this means if we flip back to our GCS directories, that we basically need to put our SQL files in the DAGs folder or the plugins folder, because these are the only ones that get synced to the web server. And then lastly, there's like general software development processes around like writing unit and integration tests for something like a Dataflow job. This topic is kind of out of the scope of this talk, but certainly something you would want to think about in your CI/CD process for a data pipeline, because we often want to make sure, okay, we're not going to deploy this DAG unless the unit tests for the Dataflow job that it invokes are all passing. And the final thing is for Dataflow and Dataproc jobs is to make sure we put these jar or compiled artifacts into a place where Composer has permissions to find them and use them. The next set of checks I like to call DAG Sanity Checks. And there's a lot of these very common problems that affect all DAGs that we can basically avoid with this test DAG validation test suite. So basically, the first layer of testing is going to be the Python static analysis with Flake8. This will catch things like you wrote horrible Python code and are missing an import statement, and even some more complex things. The next thing we want to make sure we do is run unit and integration tests for any custom operators or plugins that you're planning to deploy. And of course, this is kind of the onus for these tests are kind of on the developer. Like if you're creating a new custom operator, you need to write the tests for it. But we can wrap those tests to be discovered by our CI/CD pipeline. And finally, we have these like series of unit tests that you want to run across all of your DAGs. So the first thing to do is to kind of load up a DAG bag object and make sure that all of your DAGs parse without errors. Otherwise, we should not continue with this Airflow deployment, because you're going to end up with a web server that's complaining about your DAG. This is a bad DAG. And if we have many bad DAGs, this can actually cause issues with crashing the web server. But all of this is very avoidable if we just throw this style of test in between kind of the developer who commits to GitHub and that GCS bucket which deploys to Composer. Some other things that I like to add in there is to make sure that DAG parsing is under 2 seconds. This 2-second threshold is kind of arbitrary, but this is to hopefully shorten the scheduler loop, so we're not adding to scheduling latency due to these DAGs that do expensive operations at parse time. Some other things that you might consider throwing into your test DAG validation are asserting that the file name is equal to the DAG ID. Now, this doesn't meet every use case, because there are some times where we run into defining many DAGs dynamically within a single file. So that's why I say this is an opinion, but the root of the opinion is this can make it easier to trace, like, this DAG is failing, where's the source code for it? I know the exact file name because it matches the DAG ID. And then finally, you can assert certain things about the owners of DAGs. So especially if you're interested in like responsibility or who might be the on-call for this DAG, you want to assert that somebody set the DAG owner rather than leaving it to be like the default Airflow owner, because it's not very helpful. I'll give a quick shout out to, I took some of the inspiration for these tests from a blog by Shandu Kavar. So what I will do is hop over for just a second and we can take a peek at the DAG validation tests. So we have one, all of these tests luckily are rather simple. We load our DAG bag in our setup function. We can, okay, so I'll explain this ignore running DAGs tests later in my talk. So I'm going to skip this one for now. Here is where we are testing that all our DAGs pass correctly. Here is where we are testing that all of the DAGs have an owner. And you could imagine for your organization adding a regex check here for saying, I only have owners with @google.com addresses. One interesting caveat when deploying to Composer is that as the part of the managed service, we actually always deploy this Airflow monitoring DAG for you. And you don't have a lot of control over the owner of that. So in a lot of these tests, you'll see us skipping things about that special DAG. This is a test for asserting DAG file names equal DAG ID. And we kind of have our testing the import time for a given DAG. So let's hop back over to the talk. All right. So we've kind of like done some general sanity checks on our DAGs, but there's a whole nother suite of problems that we have when we go and deploy something to Composer. And a lot of these fall under the kind of theme of referring to things that don't exist. So a lot of times in our DAGs, we refer to either Airflow variables or environment variables or connection IDs or specific Airflow plugins. And it's very important that when we're about to deploy to a Composer environment, we know that we've set all of those variables or connection IDs or plugins, et cetera, et cetera. So the easiest way for us to do this is to leverage that special data directory that gets synced just to the workers. And we're in luck because with GCS Fuse, this syncing is very quick. So what we will see is we can basically copy our DAGs folder for a given build into this data directory, and then we can run a list DAGs on that directory. And what this does is it's similar to what the scheduler is going to do as far as like going through and parsing all of your DAGs. And this will throw errors if, for example, you refer to a file or a variable that doesn't exist. Okay, finally, we'll talk, or not finally, next we'll talk about deploying DAGs to Composer. So as I mentioned, all you really need to do is drop a file in a bucket. But if you're going to do things safely or responsibly in a CI/CD fashion, we need to make sure the sequencing of like what gets deployed when. There's a bunch of steps that we need to think about. So the first step is to stage all artifacts required by your DAGs. So we talked about this before, like putting your jars on GCS or putting your SQL queries under the DAGs folder. A little pro tip is to, anytime you have folder or files under the DAGs folder that should not be tried to be parsed as DAGs, you can add them to this Airflow ignore file. And then we need to set all of the variables that are referenced by your DAG. And kind of the best practice we can follow is keeping these Airflow variables as a JSON config in version control. And each time we do a deployment or we're validating with CI checks, we would use that JSON config to override all the Airflow variables. Okay, so another thing we run into is in the Airflow 1.10 world, we do not have DAG versioning. So if you need to update a DAG for any reason, the process you kind of have to follow is either to deploy a new DAG with a new name or to delete the old DAG entirely and then redeploy it. And we have some tooling around how you might achieve that a little later in the talk. I will give a shout out to all of the people working on Airflow 2.0. DAG versioning is a feature that is going to be available in Airflow 2.0, which should alleviate some of these problems. But a lot of us are still living in the 1.10 world. Okay, so then we copy our DAGs to the DAGs folder, and then we unpause the DAGs. Now, not everyone uses this Airflow configuration, DAGs paused on creation. But we found with customers that using DAGs paused on creation can make specifically the process of deleting a DAG a little more reliable from like the web UI. So it's also, by enabling this configuration, you kind of prevent someone who just drops a Python file into the bucket from that DAG actually getting deployed. Now, of course, if they also have UI access, they could unpause it. But it is a little bit of an added layer of safety. Okay, so what becomes pretty challenging about when we use this DAGs paused on creation is if we're deploying many DAGs at once, you have to unpause every single one of those DAGs. And there's not like an unpause all kind of easy functionality. So basically, we run into this situation where we have a lot of DAGs to unpause, and we would like to do it in parallel. So we've written a little bit of tooling in this space. So we wrote a small Golang application called deploydags. And deploydags is basically responsible for comparing the DAGs in your composer environment that are deployed to a list of DAG IDs that you expect to be running after this build. And what it will do is stop any DAGs that are running in Composer but don't appear in the running dags.txt. And optionally, if the DAG appears in both places, it will do a GCS file hash comparison to what is checked into version control and what is deployed in your Composer bucket. And this is how we detect if you've updated a DAG in version control and we're going to have to delete the old DAG and deploy a new one. So certainly you could achieve this different ways. So this replace flag is different. Some organizations would rather keep the DAG history for all versions. And basically the advice would be you should just pause the old DAG and always deploy with a new DAG name. So you could have a versioning of your DAG ID. So why did we choose Golang for orchestrating a project that is mostly written in Python? We wanted to deploy this in a rather on a rather small container in a way that could easily do things very concurrently. And Golang, it's kind of has this concept of concurrency as a first-class citizen of the language. And what can happen is when we either add or delete files from the GCS bucket, that we have to wait on this periodic one-way sync for that to actually end up on the Airflow workers and then actually end up on the web server and displayed. So what happens is if we were to just blindly run unpause, it's going to fail because the DAG will not exist yet. So this is an operation that we actually have to retry for a minute or so. So if you can imagine, if you were deploying 100 DAGs at once, you wouldn't want to have to wait for 100 minutes because you were doing them in serial. You'd want to be doing all of those polling and retries on the unpause kind of concurrently. So that's the idea behind the Deploy DAGs app. And okay, our last step is going to be talking about how to stitch this all of these tests together, as well as the Deploy DAGs app, using Cloud Build. So one thing I'll say is Cloud Build is not perfect, and a lot of like the tooling and concepts in this talk are not really specific to Cloud Build. So please feel free to bring this to your favorite CI tooling. Cloud Build is great because we have like this managed offering. It's very no ops and serverless, so costs can be very low, and it's very easy to get started. You don't have to have someone who's running infrastructure for Jenkins or Spinnaker or Circle CI or one of these more advanced CI offerings. And there's no need to contract with any other vendors if you're not interested in that. Cloud Build does have some painful limitations. So specifically for GitHub triggers, if you do this /GCB run is a special kind of comment you can use to trigger a Cloud Build. Unfortunately, it's the only special kind of comment. So this is not as flexible as something like Jenkins, where you could have a separate comment for pre-commit and post-commit to run different builds or different test suites. There's no out-of-the-box advanced queuing mechanics. So if you had many people opening PRs at the same time and you wanted to prevent them from kind of running the CI tests at the same time, you'd basically have to solution that yourself. And it does not run in your customer project network. So you need some either access to the Kubernetes master, basically, to run any of your Airflow commands. So what is the workflow going to look like? We will use GitHub triggers to run our like unit and integration test as soon as someone opens a PR, and this pre-commit automatically runs. And then the post-commit, which is going to actually deploy all of the DAGs to a CI composer environment, is gated on this GCB run command or a comment. Cloud Build has a bunch of like convenient builders to use for building jars with Maven or building Docker containers, which is how we'll kind of package up our Golang deploydags app, running gcloud commands to copy GCS files, run composer, Airflow commands, etc. And you can run small applications in containers as well. So what we are going to be looking at here is what happens when we do this CI test. So what will happen is we have a Docker file that will run our basically Airflow unit tests on any of your plugins or your DAGs. So this includes the DAG validation tests. It also will run any of your Dataflow Java tests. It runs a basic Maven test. And there is some smart tooling in here to kind of discover what tests need to be run. And the basic heuristic for this is each directory can optionally define a Cloud Build file. And if that Cloud Build file is present, and in this PR, we are modifying anything under that directory tree, then we will run that Cloud Build file. What this allows us to do is have like different systems for different pipelines. So like if some people in your organization are building with Maven, but other are building with Gradle for Dataflow jobs, they can kind of define how their code should be tested just on the scope of an individual directory rather than on the entire organization having to do the same thing. And this also saves us from running all of the tests on every PR because oftentimes that's unnecessary. So once all of our unit tests have passed, we will use various cloud builders and the deploydags image to kind of ship our artifacts to GCS buckets in the staging or this CI environment. And then we will run this deploydags image and point it at a CI composer environment. And basically, once the DAGs are in this CI environment, you can add additional checks to your cloud build file that might trigger a DAG to run and assert that certain resources got created or your DAG did what it was supposed to. And if that all goes well, then you might want to push to prod. So this is just a copy of what we did in the CI environment. If all of your CI checks as defined in these cloud build files pass, we will push all of the artifacts to this artifact project. And this is kind of a way to have this like demilitarized zone between your CI infrastructure and your production infrastructure. Basically, the CI infrastructure builds these artifacts and pushes them to the artifacts project. And when you're ready to like cut a release and push to production, you'd run a very similar prod cloud build file, but instead of running all of these tests, it's just going to pull all of these existing artifacts and again run the same deploydags application, but this time pointed at your production composer environment. So we can go and we'll look at an example PR that deployed 22 DAGs. And I can talk a little bit about this run relevant cloud builds, which I spoke about on the last slide. So give me one moment. So for this summit, I opened a PR and I can show you basically what it does. So, this is zoomed in too much. Give me one moment. All right, so what we can see here is we have this running dags.txt, which is our config of what should be running. And if you look closely at these DAG IDs, they're mostly plagiarized from the Airflow examples, but we have a few special ones that are one that runs a Dataflow word count job and one that runs a Dataproc Spark job, because we thought these would be useful examples because most Composer users are orchestrating jobs on other GCP data services. So basically, I am checking in all of these DAGs. I added them to the config. So let's take a look at what happened. So basically, this pre-commit ran automatically, and this post-commit ran because I am a maintainer of the repo and commented this GCB run. So let's take a look at some of these builds. So what we will see is here is our pre-commit, and what the pre-commit does is basically it runs that run relevant cloud builds script. And what this will do is it will dynamically submit many cloud builds for any of the subdirectories where it recognizes there are files changed here. We have to rerun all of these tests. And what's nice about this is all of those, in this case, I only edited this composer directory because I was only pushing new DAGs. So what basically happens is it only ran the pre-commit for linting on the entire repo, but then only ran the like unit tests of those things relevant to Composer. And even though we use this cloud build to trigger another cloud build, all of those logs kind of come back here. So what we can see is we're setting up inside the cloud build container, we're setting up like a local Airflow instance. We're uploading our variables. So this came from that JSON config that we talked about having in our repo. And as you can see, a bunch of these things are templated. The purpose of this is that you might want to point to a different project or a different bucket across different environments that you are deploying to. So many organizations have like a dev, a test, staging, prod. And what we can do is in our cloud build file, we can actually render these at build time. So we are running, this is running a unit test on a custom plugin that one of our DAGs uses. Then we run our DAG Sanity Checks that we kind of reviewed earlier in the talk. We can see all of these tests are passing, and the entire build was a success. So now we get to the more interesting post-commit. So the post-commit similarly will run relevant cloud builds, but these cloud builds have a different purpose. Instead of running the tests for each directory, they're responsible for deploying the artifacts for each directory. It will deploy our SQL queries for BigQuery using GSUtil. It will render our Airflow variables. So we talked about how we have these different values templated, and we're using a utility called nsubst, which allows us to substitute environment variables. It's a GNU tool, but it's one of these convenient community cloud builders that exists for you to kind of use out of the box. We're going to copy some more files to GCS, like our Airflow ignore file. We're going to run and import variables. And so this is running this gcloud composer environments run, and it's importing all of these variables from the rendered JSON config on your actual composer environment rather than the local version we kind of did testing against. We're going to deploy our plugins with GSUtil. And then we're going to stage all of our DAGs for this integration test. So we talked about this in the slides where we have this data directory where we can run a list DAGs against the composer environment as kind of a last-ditch effort to make sure we're not referring to anything that doesn't exist in the composer environment. So if somebody refers to a variable in a DAG that they didn't set in the JSON config, this is the step that would bomb out and prevent this DAG from actually getting through to Composer. So run that DAG parse integration test, which, like I said, is a list DAGs. We'll clean up after that test, and then we will basically build and run the deployed DAGs Golang application. And the logs for this are kind of interesting because they tell us what's going on. So for this build, it read the running dags.txt and said, okay, there are these 20 some odd DAGs that I should be running after this deployment. Then it went and ran a list DAGs against the composer environment, and there were no DAGs running. So what it does is it pulls down the DAGs and it realizes, okay, I have no DAGs that I need to stop for this iteration, but I have all of these DAGs that I need to start. It does some fancy stuff to respect your Airflow ignore file. And then it basically tries to unpause each of these DAGs. So we've copied all of these to the DAGs bucket, but now because we have this DAGs are paused on creation config set to true, all of the DAGs are paused, so they're not running yet. And this is where we kind of go through and run the first unpause command. And then all of these will wait for 60 seconds to retry. And the reason they have to retry is we're waiting on this sync between the GCS bucket and the file system of the workers. So what we'll see is we're now retrying, and you can see a bunch of these like out of order logs, which is because each of these retry loops is happening in a separate Go routine. And what we'll see is some of them actually took a third retry. Let me close this. But ultimately, they all succeeded. And we can look at our happy Airflow environment over here, where we deployed all these 22 DAGs. They've been running for a while, and we can look at the variables that we kind of pushed as well. So you can see that these actually did get rendered during cloud build. So let's move towards the end. Oop. So I will mention that all the code for this is open source. So if you're interested in using some of this tooling yourself or playing around with it just as a demo, there is Terraform to kind of spin up all of the CI artifacts and projects and production projects, as well as examples of all this getting done in cloud build. So now we will talk about like what's next for this project. So there are many improvements we want to make. We want to continue to develop this as an open source project with like the key goal of being like examples of how to do common CI tasks when you're interacting with Cloud Composer. So one of the things we want to do is have some better test isolation. So right now, if we were to have parallel PRs on the repo, they'd both run their integration tests against the same Cloud Composer environment. And as you can imagine, they might stomp on each other and cause hard to debug failures. So we're going to be solutioning a way to kind of lock the CI environment so that one of the integration tests basically gets stuck behind the other one. And the reason for doing this is it's better to have tests that are isolated, but we also don't want to pay for a composer environment for every single integration test, because this would be very expensive, and they take like 30 minutes at least to deploy. So we will actually save time by having kind of a queue of tests to run, rather than spinning up a separate environment for each test. Some other things we want to do is improve how this solution interacts with completely private Cloud Composer environments. So a challenge we run into with Cloud Build is that all of the Cloud Build steps run in a network that is not your customer network or not the network on which your Composer environment is running. So this makes it very hard to run Airflow CLI commands easily because you don't have that network connectivity. So this is a solvable problem. We can have Cloud Build access your Composer environment through a Bastion host or something like this. Portability. We want to be able to generalize this deploydags Golang app to work with non-Composer Kubernetes deployments. So basically, we don't need to depend on this gcloud Composer environments run command. We can actually just use the Go Kubernetes client to run the various Airflow CLI commands. That's a little bit of an improvement we're looking to make. And then we want to add lots more example DAGs to this of like, what does a best practice look like when I'm running BigQuery enterprise data warehouse style DAGs? And that's about it. It is an open source project, and we gladly welcome any contributions for Composer users out there who are interested in using this tooling, have questions, open up GitHub issues. Similarly, we've created a new Slack channel for Airflow CI/CD in general. So this is not specific to Composer, but we want to talk a lot about how people are managing their testing and deployments of DAGs. And finally, I'm going to have a few thank yous. So first of all, I'd like to thank my employer, Google Cloud Professional Services, for enabling me to work on cool things like this, give talks like this, and work with cool customers, because ultimately our customers are what inspire us to do work like this. I'd like to thank Ben White from OpenX. He was kind of like the inspiration for this talk, in that he gave us a lot of the requirements and initial feedback on a POC. I'd like to thank our partner SpringML. Ini was a great partner in implementing a POC of similar concepts at OpenX, and he's got a great blog which you can check out. I'd like to thank the Airflow community leaders, Yadek and Camille. They got me excited about Airflow. They are heroes of mine, and they were hugely impactful in getting this summit together. And I'd like to thank my partner, Janelle, for constant love and support. And now I think we can go on to Q&A session.
Thank you. Thank you, Jacob, for excellent presentation. And let's see if we have questions from the audience. Okay, I think they should appear in the chat in a second, but let's see. Okay, we have a question from, I think it's from Yarek. Have you used Pylint plugin for DAG validation? And he gives an example of from the book that Bas Harensak wrote, and he's asking if you have seen it, and he says there's some great validations there.
I have not seen this Pylint plugin yet, but I'd gladly add this to the repo. We basically just run Flake8 for static analysis initially.
Great. There's another question. Will you be providing a GitHub where to get your unit test methods?
Yeah, absolutely. So it is available at jaketf/CI/CD for data processing workflows, but the links will be in the slides, which I believe are being shared with everyone.
Okay. Yes, it's a reminder for every attendees. All the slides from the speakers who agreed to share them, they will be posted on the Airflow Summit after the summit is wrapped up. So stay tuned.
I can put a link to the GitHub in the Airflow Summit attendees Slack channel, just to speed things up for you guys a little.
Yeah, I think that's awesome. And also, like, if Jacob is on the Airflow Slack channel, if you have more questions, you can reach out to him there. Okay, so there's another question. What would you recommend to pushing through CI/CD remaining Airflow components other than variables like connections, pools, etc.? Even composer components like Python packages, dependencies, and things like that.
Yeah, this is an awesome question. So I think that there are certain things that are kind of infrastructure level, and I think we actually have to treat PyPy dependencies as infrastructure level, because they really require that you interact with the Cloud Composer API in a way that provisions your environment with all of the PyPy dependencies you need. So an approach like we've taken in the past, and we have Terraform in this repo as well for kind of deploying Cloud Composer environments. You can specify PyPy packages in that Terraform config. So what we could do is add a step to our cloud build to always rerun this Terraform. Terraform is kind of industry standard these days for like iterative infrastructure deployments. So for PyPy dependencies, that's definitely what I'd recommend. One of the reasons we left that out is if you, on your very first cloud build on a new repo, the Terraform takes a long time to provision your Cloud Composer instance. And we wanted to kind of decouple the concerns of infrastructure provisioning and like CI/CD testing. So today in the repo, what you'd have to do is basically have someone run the Terraform manually to update the Python PyPy dependencies and then continue on with your CI tests. So
Okay.
let me see if I answered this whole question. So what would you recommend for pushing through other components? So adding connections, pools. So pools, I think I'm going to ignore that one because I think the composer team has been locking down the pooled configs more recently. So I think it's a little less relevant. And then uh, for connections, basically we could add more Airflow CLI commands to the cloud build to push this. Unfortunately, for my use cases, we didn't really need additional connections. But one crucial thing that is in the repo is kind of a hook for doing that in your local Airflow image. So when you think about like the different series of tests we run, all of your unit tests will fail if they refer to connection IDs that you didn't provision initially in that local Airflow environment. So we have this like run unit tests or like run Airflow unit test script that handles kind of adding different connections. And the way that works is it can actually pull your composer environment for all of your connections, pull down just the connection IDs and just mock out all of the actual sensitive information like your username, password, service account key, etc., just to make sure those unit tests pass.
Thank you. There's another question from Yarek. How about more insightful tests? For example, if you're not accessing database in the DAG during parsing.
This is interesting. So I think this can be very difficult kind of test to write, as Python's a rather dynamic language. I will have to think more carefully on how you would prevent this or check this. So I think the spirit of the question is if you have something in your DAG file that is going and doing something malicious on the Airflow database because the scheduler and the worker have direct access, um, how could you prevent DAGs from doing things they shouldn't, or basically accessing the database outside of a hook or operator that's approved by your organization? Um, I think there are certain ways you could mitigate against this, but it is not going to be um, completely foolproof.
Thank you. I think those were the all questions from the audience. And thank you, Jacob, so much for insightful answers. And I want to remind everyone that we have Ask Me Anything session with PMC members and committers. It's going to be late PST time, 11 p.m. Do your math, it might be early morning in Europe. And another reminder, we're going to have a fun event on Friday after the session. So grab your drinks and grab your food and be ready to spend relaxing time with the community. So I'm really looking forward to see you all there. And with that, I think I will wrap this up. And thank you, Jacob. Thank you, everyone. And
Thanks so
everyone,
much for having me.